Timeless Concepts from Physics Helpline. This is a video tutorial series through which we will sharpen our problem-solving skill. First, we will analyze the problem on hand to find the related concepts. Then, using these, we will develop a method which will produce the solution. This will help the students aspiring to get into IIT to understand the much needed advanced theories and applications in physics. In this video tutorial, we will discuss 3 more multiple choice questions with only one correct option in kinematics, which are solved using the concept of relative motion. The questions are as follows. Question 1. A man standing on an escalator takes time t1 to reach the top of a tower when the escalator is in motion and takes time t2 to walk up when the escalator is not moving. Then the time taken by him to walk up the moving escalator is. The options are t1 minus t2, t1 plus t2, t1 t2 divided by t1 minus t2 and t1 t2 divided by t1 plus t2. Question 2. The driver of a train moving with speed 20 meters per second sights another train moving with speed 4 meters per second on the same track in the same direction. He applies the brakes, which provides a constant retardation of 1 meter per second square. Then the minimum distance between the two trains so that there is no collision is. The options are 80 meters, 128 meters, 320 meters and 400 meters. Question 3. A ball thrown upwards with velocity v from the top of a tower reaches the ground in time t1. If the ball is thrown downwards from the same point with the same speed, it reaches the ground in time t2. Then the time taken by it to reach the ground when it is dropped from the same point is. The options are t1 plus t2 divided by 2, t1 minus t2 divided by 2, root over t1 into t2 and root over t1 plus t2. Let us first solve the problem in question 1. The situation is shown in the figure. It is about a man moving from the bottom of a tower to the top in 3 different ways. In the first case, he stands on the escalator and uses the moving escalator to reach the top. It is given that time taken in this case is t1. In the second case, the man walks up the stationary escalator to reach the top. The time taken in this case is t2. In the third case, he walks up the moving escalator to reach the top. Let the time taken in this case is t. We are required to find the value of t in terms of t1 and t2. In the figure, A and B respectively are the bottom and top of the tower. Let the distance AB is equal to s. Let the walking speed of the man is equal to u and speed of the escalator is equal to v. Therefore, when the man walks up the moving escalator, his speed relative to the ground is equal to u plus v. In the first case, speed of the man relative to the escalator is equal to 0. Speed of the escalator relative to the ground is equal to v. Therefore, speed of the man relative to the ground is equal to v. Distance covered is equal to s and time taken is equal to t1. Therefore, we have s is equal to vt1, which implies v is equal to s by t1. In the second case, speed of the man relative to the escalator is equal to u. Speed of the escalator relative to the ground is equal to 0. Therefore, speed of the man relative to the ground is equal to u. Distance covered is equal to s and time taken is equal to t2. Therefore, we have s is equal to ut2, which implies u is equal to s by t2. In the third case, speed of the man relative to the escalator is equal to u. Speed of the escalator relative to the ground is equal to v. Therefore, speed of the man relative to the ground is equal to u plus v. Distance covered is equal to s and time taken is equal to t. Therefore, we have s is equal to u plus v into t, which implies u plus v is equal to s by t. From the equations 1, 2 and 3, we get u plus v is equal to s by t, which is equal to s by t1 plus s by t2. This implies 1 by t is equal to 1 by t1 plus 1 by t2, which is equal to t1 plus t2 divided by t1 into t2. Therefore, we have t is equal to t1 into t2 divided by t1 plus t2. Therefore, the correct option is D, which is the answer to question 1. Now, we will solve the problem in question 2. The situation is shown in the figure. We will use the following concept to solve this problem. There will be no collision if the relative velocity of the two trains becomes 0 just before collision. Initially, the distance between the two trains A and B is equal to s. Initial velocities of the two trains respectively are 20 meters per second and 4 meters per second in the same direction. Retardation of train A is equal to 1 meter per second square. Therefore, acceleration of train A is equal to -1 meters per second square. Acceleration of train B is equal to 0. Therefore, acceleration of train A relative to train B is equal to -1 meters per second square. Initially, velocity of train A relative to train B is equal to 20 minus 4, which is equal to 16 meters per second. For no collision, the final relative velocity of the two trains should be 0. Therefore, we conclude that in covering a relative distance s with uniform relative acceleration of -1 meters per second square, the relative velocity decreases from 16 meters per second to 0. For this, we make use of the kinematic equation v square minus u square is equal to 2as. Putting the values, we get 0 minus 16 square is equal to 2 into -1 into s. On simplification, this gives S is equal to 128 meters. Therefore, the correct option is B, which is the answer to question 2. Finally, we solved the problem in question 3. The situation is shown in the figure. A ball is projected from the top of a tower in 3 different ways. We will use the convention that displacement, velocity and acceleration are all positive in the upward direction. Let the height of the tower is equal to h. In the first case, the ball is projected upwards with speed v. Therefore, initial velocity is equal to plus v. Acceleration is equal to minus g. Time taken is equal to t1 and displacement is equal to minus h. Using the equation s is equal to ut plus half at square, we get minus h is equal to vt1 minus half g t1 square. This implies h is equal to minus vt1 plus half g t1 square. In the second case, the ball is projected downwards with speed v. Therefore, initial velocity is equal to minus v. Acceleration is equal to minus g. Time taken is equal to t2 and displacement is equal to minus h. Therefore, we get minus h is equal to minus vt2 minus half g t2 square. This implies h is equal to vt2 plus half g t2 square. And in the third case, the ball is dropped. Therefore, initial velocity is equal to 0. Acceleration is equal to minus g. Time taken is equal to t and displacement is equal to minus h. Therefore, we get minus h is equal to 0 minus half gt square. This implies h is equal to half gt square. From equations 1 and 2, we get minus vt1 plus half gt1 square is equal to vt2 plus half gt2 square, which gives v into t1 plus t2 is equal to g by 2 into t1 square minus t2 square, or v is equal to g by 2 into t1 minus t2. Again, adding the equations 1 and 2, we get 2h is equal to minus v into t1 minus t2 plus g by 2 into t1 square plus t2 square. Putting the value of v from equation 4, we get 2h is equal to minus g by 2 into t1 minus t2 whole square plus g by 2 into t1 square plus t2 square. Again, from equation 3, we get 2h is equal to gt square. This gives gt square is equal to g by 2 into t1 square plus t2 square minus t1 minus t2 whole square. On simplification, this gives t square is equal to t1 into t2, or t is equal to root over t1 into t2. Therefore, the correct option is C, which is the answer to question 3. This completes the answers to the questions.